Good morning again, everybody. It's great honor to welcome everybody here, especially that we come from all over the world to Vietnam, to Hanoi. And I hope you got a pleasant flight and have a good time so far. And we'll have more time to explore the city later on. But let's now get on our business and start the conference now. Let me introduce myself first. I'm the Xuân Văn Nguyen. I'm the associate professor from Middlesex University in London, United Kingdom. And I'm executive chair of the conference. And you may receive some of my emails in the past. Let me quickly introduce some of our, maybe now we start with our co-organizer, Lê Quý Đôn Technical University in Vietnam, co-organizing company. Let me introduce Professor Lê Kỳ Nam. He is the vice president of the university. Thank you. And also it's my honor to introduce that Professor Hamid Afghani from King's College London. He's a co-founder of the ICT conference. And you know, this is the 26th event edition of the conference. So it has been since 1994, 26 times. And this is the first time in Vietnam. And let me see Professor Farooq Masvati. Yeah, Professor Farooq Masvati from Iran. He just joined us today. And he is the co-founder of the ICT conference as well. And now, let me introduce our three keynote speakers. And let's start with Mr. Siavas Alamunti. Do you hear the names sound familiar? Siavas, maybe that is you. Thank you. He will open the talk soon, so we got more chance to give introduction to him. And also the second speaker who will give a talk tomorrow morning. And that is my honor to introduce Mr. Malik Tati Palmula. He's the CTO of the Ericsson in Silicon Valley, USA. So it's a great honor to have you here. And he just fly all the way from the US, right? Thank you. And now our third keynote speaker, who is local here. And if I can ask if Mr. Phan Thanh Sơn, are you here? Okay, maybe he arrived a bit later. Mr. Phan Thanh Sơn is the CEO of the FPT Information System, one of the company that has contributed a lot in the smart cities, smart transportation, and he's doing a lot of the software thing, and hopefully he can give us a very informative keynote on the third day. So please join him as well on the third day. So now, yeah, thank you. He's not here, maybe he'll arrive later. Let me introduce a very short opening talk from our co-founder, Professor Hamid Afghani. Can you have a few words for us? Thank you.
Good morning, everybody. Welcome to 26th ICT conference. We are pleased to hold this conference in such a beautiful country and city. So far, it's my first journey to Vietnam, and I was very impressed, particularly about friendship, hospitality of Vietnamese people. My co-founder, Farooq Marvasi, Professor Marvasi, and me, in 1994, founded that conference. We never thought that this conference would last so long, 26 years. We thought it's one in 1994, which was held in Dubai, Emirat. So this is first and last conference. Thank you to you encouraging us, participating the conference, since 1994. And hopefully, as long as we both alive, that conference would carry on. Again, thank you for participating. Enjoy the conference and that beautiful city. Thank you.
Thank you, Professor Hamid Afghani, for the kind words. So now, very important that we need support and help from our local organizer, co-organizer. Without them, we wouldn't be able to organize this conference. So it's my honor to introduce you to Professor Lê Kỳ Nam again. He's the Vice President of the Lê Quý Đôn Technical University. Can you please have the few words for opening talk?
Good morning, ladies and gentlemen. First of all, on behalf of Lê Quý Đôn Technical University, I would like to welcome all of you to Hanoi, Vietnam, to participate the 26th International Conference on Telecommunication ICT 2019. I'm pleased to know that this event is not only a research forum for professionals and scientists to introduce new technology and research achievement, but also an excellent opportunity to boost the collaboration between university and companies. I am very happy to hear that among a lot of submitted manuscripts, there are 98 high-quality papers selected for presentation at the conference. The conference also features 3 keynotes and 5 tutorials from renowned world-class researchers in area. As you know, Lê Quý Đôn Technical University is one of the nation's key universities in Vietnam and one of the nation's top universities in science and technology. We offer multidisciplinary undergraduate and postgraduate programs in engineering and management. We have also established international collaboration with many foreign partners. Aiming at building a research university, we are conducting various joint research projects with industry as well as research institutions. Therefore, I think this conference will be a wonderful chance for our staff, our staff members to learn from leading researchers in the world, and I believe that this event will be a valuable opportunity for all participants for deeper collaboration. Thank you very much for your attention. Thank you.
Thank you, Professor Lê Kỳ Nam. And actually, yes, I just like discussed by Professor Lê Kỳ Nam that I would like to go through a little bit of the. We received 196 submissions, and there 96 paper has been accepted, and we all are here now presenting those papers. And there will be 15 regular technical sections, and 5 tutorials, and also the 4 special sections. And of course, that, as I mentioned, there are 3 keynotes. Wow, I look at the title, all fantastic. I'm sure that you will join us to attend all the keynotes and all the sections here. So, again, yes, of course, the conference cannot be held without you, all the attendees. So I would like to extend my thank yous to all of you. For some of you fly very far from different sides of the world to come into Vietnam. I really hope that you will enjoy the conference, and at the same time that don't forget to enjoy the city as well. Try to see the city, how different it is compared to the city in Europe or in the US or in North America, you can see. So just again, thank you very much. Now I'm going to maybe leave time, a little bit time for 5 minutes before we can have our very, I'm sure that would be very interesting talk from Siavas, Mr. Siavas Alamunti. Yes, so I will give maybe a more introduction a bit later, but I think you ready? Okay, so maybe then you know that the name Alamonte just reminds us, wow, it is just very famous space-time block code that we all read his paper. I'm not sure at how many citations you have for that paper. It's like 17,000 citations maybe. 20,000, yeah, he corrected me. And yeah, wow, the name itself need no introduction. So maybe I just stop here and give the stage to Siavas Alamunti. You can introduce yourself. Thank you.
Thank you very much, Professor Nguyen. It's a pleasure to be here. Professor Armomi, thank you very much for inviting me for the keynote. It's my first time in Vietnam, and as Professor Armomi mentioned, it's an amazing place. I've always wanted to visit, and this is a great opportunity to come here and talk to you, and also to hopefully have some time to do sightseeing here and connect with many of you. I'll be available right after the talk if you have any questions for me. So what I'm going to talk about today is not about my own space-time coding and all of that. I've been, my passion has been edge cloud or cloud decentralization. And the reason I chose that because a few years back we realized that we're doing really well with physical layer design, antenna design, or connectivity, but there was this huge issue with the cloud itself and some of the choices that we had made very early on about the architecture of the communication networks and the way applications are brought into end users, whether for consumer or enterprise applications. So I'll try to kind of tell a story about this so that you see where I started and then get to some of the very high-level technical details. Given that these are not familiar communication theory for the crowd, I've tried to keep it at a very high level at the software architecture so that you can kind of see the view that we have formed around edge cloud. So edge has been a major topic in the last couple of years. We have been obviously 10 years. If you could actually move from the cameraman, if you could move from the presentation, you're blocking the presentation. If you move a little bit. All right. So with edge, there's a lot of confusion around the edge. Depending on what industry you're with, people's interpretation of where edge is different. And that's why I use this parable of the blind man and an elephant. The story is, I'm sure that a lot of you have heard this story, that they bring a few blind men and they get them to touch various parts of the elephant to figure out what it is. The man that touches the trunk figures out that it may be a snake. The one that is touching the leg thinks that it's a tree stump. The one touching the ear thinks that it's a fan in the original story, but in here it says a sheet of leather. And the one touching the tail figures out that this must be a mouse. And this is something that, depending on what industry we come from, our outlook on different things and new things may differ from each other. And that's what we see in our industry today. I think I moved this a little too fast. So if you look at the telecommunication industry and specifically cellular communications, those that are building equipment in that industry think that perhaps edge is the base station. The ones working on IoT figure out that the edge is an IoT hub. The ones that are building boxes and routers call edge fog computing. And those that are in the blockchain movement and decentralization and mesh technologies and complete open peer-to-peer call the edge perhaps the mobile. So in order to kind of rise above all the noise, I tried to define edge in a simpler way. I generally like simple definition of things. And the way I looked at cloud, and our company looked at cloud, was very basic. We kind of looked at what cloud had to offer, cloud at the end of the day, and connectivity. So as you see, all of these elements, every device has these elements, especially the mobile phones today, perhaps are as powerful as some of the servers just a few years back. And also, this will continue with Moore's law. As time goes by, these devices are going to become even more powerful. CPU, memory, and storage is going to get cheaper. So any device could actually act as a cloud server. So when we talk about edge cloud, and it's in a scenario with if any device will participate in the network as a cloud server, we say that an edge cloud has been formed. So it's a very simple definition of edge cloud. So why do we want to do this? Why edge cloud to start with? Central cloud has been an amazing enabler for the app economy, mobile internet. What basically drove it was to make sure that the cost of computing and the reachability of computing is there for developers to be able to build applications and make it available to masses. When we started, this was, as you know, internet was about us getting access to information that was over the web, right? So that was the major reason for it. But today, after years of having the cloud, we're now facing the challenges for the future. The first challenge of this is really the cost of cloud hosting, right? When we talked about cost of cloud hosting a few years back, there was a lot of pushback, especially, for instance, with Mimic when we were trying to do fundraising with VCs in Silicon Valley. A lot of us said, well, what are you talking about? Cloud is cheap. And it wasn't just until recently, and I think the first really big news was in 2017 when Snap, the company that provides the social media Snapchat, announced that they had made a $1 billion deal with AWS and a $2 billion deal with Google on cloud hosting services for 5 years. So talking about a company spending $3 billion in cloud hosting costs. So by no means cloud is cheap. And there's recently also Lyft announced that for the next couple of years they'd be spending about $300 million in cloud hosting costs. Cloud is cheap as long as you don't use it that often. But if your application becomes very successful, then the cost of cloud can be a major inhibitor. And of course, the other big problem of central cloud is communications, bandwidth, and latency, because the way it works is that the data has to travel from what we call client devices back to a server in data center that may be miles away. And because of limitations of speed of light, obviously, latency becomes an issue, and of course, these bits have to travel over the air or over wired networks back to servers in data centers. And the other big issue is, of course, data privacy. Again, if I tell you the story that a few years back, again, going to the VCs and talking about data privacy and edge cloud, the first response that we used to get was that nobody cares about privacy. And that was the case a few years back. until we realized what the byproduct of this, of sharing data with third parties can be, with the fiasco with Facebook, as you know, with what happened in Egypt, the presidential elections in the US, we realized that if we make data available to people, they can manipulate that data and drive us towards perhaps end results that may not be very good for the population. So data privacy is also a big issue. And the reason is also the choice of architecture that we have had. The other issue is vendor lock-in. Now there's basically 3 companies that are controlling about 90% of the data that we consume. These are cloud providers. At least in North America and Europe, it's really Amazon, Google, and Microsoft. They're amazing companies. They have done a lot. But it doesn't make sense for all our data to be controlled by 3 large companies. And of course, in China, we have Alibaba, and there are others as well. So vendor lock-in is a big issue as well. There's too much power being concentrated in the hands of a few. And this thing is going to continue with what I call a data tsunami. The big thing, the 2 big kind of trends that make the central cloud a serious challenge for us are one that we're all aware of, which is the number of devices. We're now hearing that 200 billion devices by just next year. But most importantly, the way the role of these devices has changed on the network. We used to use internet as a way of downloading information from a central place, but that role has changed. Now we have become we have changed from consumers of data to producers of data. We're generating videos, pictures, and also not that's for the social media, of course, but also for even industrial applications, sensors, cameras, LiDAR, all sorts of information that is being produced on the edge of the network. So where the data is generated has completely changed. So that means that the software architecture needs to be revisited. And we have an architecture is from the days that we used to download information. Now we are uploading a lot of information. So how this software architecture needs to change. And that's what I'm going to talk about a little bit today in order to explain the rationale of edge cloud. Why would we want to use edge cloud in the first place? So we believe that edge cloud is the right architecture for the future because, first of all, it will scale with devices. So today, with the current cloud architecture, if you add devices or client devices on the edge of the network, you have to add more servers on the central cloud in order to support them. That's how it works. With edge cloud, meaning if the devices can participate as servers, the cloud itself is going to get larger because now the computing resources on the edge are being used for cloud itself. It's faster. It's faster because of latency issues. So if you and I are in this room and we want to communicate and I can be a server to you, the data doesn't have to travel miles to a data center. So obviously the latency is lower. The bandwidth usage is also lower. So also it's cheaper because we don't hit Amazon, Google, and Microsoft's cloud services as often. We generally have much more local communication. And also it has better data privacy because data can remain as local as it possibly can be. So if I can serve you a video from my own device, then the threat of privacy is much lower because I'm not sending the data to a third party and is less susceptible to abuse. And then last but not least is much more efficient, energy efficient and bandwidth efficient at a system level. So how are we going to do this? In order to kind of understand the future, sometimes it's good to look at the past and see where we have come from. In the early 60s till about 1980, we had mainframes. Unfortunately, I'm old enough just to remember those days. That was really a central architecture. Then with the PCs, we went to a decentralized architecture. If you remember, we used to put floppy disks and we would load the software so the application would be loaded on the device and if we use it. So that would be a decentralized architecture. Then starting in the 90s, we went to a client-server architecture where we had these kind of thin clients from a computing and storage and memory point of view, where basically screens that would process information and the application would be hosted on central servers. And with central cloud, that architecture was evolved so that we could easily reach computing resources in servers in data centers. So again, that was kind of a centralized architecture of the cloud. And we're hoping that 2019 onwards, we're going to go back to a decentralized architecture again. And again, I call it the pendulum because it's very analog. It's not black and white. Obviously, throughout these years, we had variations of these technologies. But as we see it today, the dominant architecture today is central cloud, whether hybrid or private. The other important thing to look at is actually how the software architecture has evolved. And this is very important. In early days, where we had the client-server architecture, generally a client would be for rendering of information, and the application would be on a server in a data center. And that application used to be monolithic. That means that it was basically a function in one big box, right? And there would be an API gateway, perhaps in the middle, and of course you have the network as well. Then we moved to the era of microservices. So these monolithic applications were broken into smaller pieces. So we entered the era of app and services. So about 20% of the businesses today have evolved to this microservice architecture. It's something that it's now very common and everybody is talking about, but we have to also realize that 80% of our industry hasn't even got there yet, right? So the advantage of this is obviously if you want to make a change to your monolithic software architecture, it may take months or years to do this. When you have a microservice architecture, you can easily update various parts of your system. So if you see on the left hand, we're showing the device. In the middle is the network. And then on the right side, we have the cloud core. As communication engineers, we usually have never dabbled to come and understand this API gateway and microservice. We really need to start thinking about this because communication has to be looked upon end to end in order to understand where you need to optimize and where you need to put some of your innovations in order to make sure that end to end you're getting the right result. So the other trend was going from centralized to distributed. So on the top picture that you see the app and microservice, and then with the advent of virtualization and container technologies such as Docker and CoreOS, some devices now have the capability to host microservices. For instance, now you can have a Docker container hosting a microservice on an x86 machine on a regular server, for instance. And interestingly, the industry has come up with ideas as well to host microservices on typical network equipment. And that is something that in our circle of communication engineers, perhaps we're most familiar with in terms of edge. That's what we call edge, and that's a standard that was formed. Name has changed to multi-access edge computing today. And that means that you start hosting microservices on networking equipment. What does that mean? You know, we have all of this infrastructure like base stations and the core network and all of that. Now, the idea is that you put servers within the same infrastructure and start hosting what would be cloud type applications in terms of microservices. So that's what mobile edge computing looks like. Now, from a network architecture point of view, this is what it looks like. So you've got devices, and now imagine if we manage to host microservices on all the devices, then we can connect also. So we have the cloud core, and we have the devices talking to the cloud. And this is happening today with, again, container technology and all of that. And even cloud service providers such as Amazon have come up with technologies like Amazon Green Glass. There is Google Cloud IoT. Variations of ability to host what is usually a back-end data server technology on a device, right? Today, this is available, as I said, on, for instance, Linux-based machines using container technology. The next step to this is making sure that these devices can also act as servers to another. Right now, everything is managed through the cloud core. If you break that and now devices can communicate directly at a microservice level, then you get this massive cloud, which we would call edge cloud. So from a network architecture point of view, this is neither a star, so this would be the star, right? We've got a central element. If you would have only those devices connected, that would be a mesh if you didn't have the cloud core. Now we have a hybrid architecture where devices and the cloud core can join and provide what we call edge cloud. And this kind of reminded me also in the early days of MIMO. There was, if you remember, there was a lot of discussion and religious fight for MIMO diversity, MIMO spatial multiplexing. Some people were saying, oh, MIMO should be used for diversity. Others were talking about MIMO should be for spatial multiplexing. And the reality was that neither of those were the right thing to do. You would have to have intelligence on the network, do link adaptation, and depending on channel conditions, decide where MIMO diversity should be used and where MIMO spatial multiplexing should be used. So a hybrid approach. The same holds true with the cloud. Certain functions need to be centralized. Functions such as registration, authentication, authorization, right? So when we talk about decentralization of the cloud, we're not talking about this in a religious way and say everything should be decentralized. What should be decentralized are those elements that are not necessary. So all unnecessary trust elements in a network should be removed because they add overhead in terms of latency, they create issues such as privacy, and that's why we have ended up where we have ended up today, because we don't have a hybrid approach. So this is how we see the network architecture evolving. So what are the use cases for edge cloud? That's, again, you go and read about this, and it's very confusing. To me, it's very simple. Central cloud is a special case of edge cloud. So all the applications that we see today that are being used with central cloud, all the use cases can be supported with edge cloud, right? Because in the worst case, you don't have edge as a server, but you still have an edge cloud, right? So depending on what vertical you are, the benefits of edge cloud may vary. And the reason you use edge cloud may differ from one another. For instance, based on the experiences now that we have had with some of our partners, for instance, in gaming, the big driver for edge cloud is latency and also cloud hosting. For health and wellness is data privacy. You know, it's one of the most perhaps challenging things in the health industry in terms of having health information being shared. Usually, at least in Canada and the UK and US where I lived, every time I went to a doctor, I had to tell my doctor exactly as it was as if it's the first time they see me. Nobody has any history information on me unless I have been going to that same doctor for years, right? So they ask you, they get you to fill out a form. What kind of allergies you have? What was the last surgery you had? And the reason for this is because of data privacy. These different networks that are out there are not allowed to share your personal information. And it's for our protection, in fact. That's a funny thing. It's not a conspiracy to hide this information. It's for our protection. So the solution to that is that we need to be in control of our data and be able to share that data. So in health, the driver for edge cloud is data privacy. In manufacturing, it may be hyper-local activity and the cost of cloud and the latency. For instance, if you want to have robots response to commands based on some intelligence or AI, you want that to be local, so you need edge cloud, and the driver for that may be latency. So all the use cases for edge cloud are going to be supported. And also then for enterprise, as I said, only, and this was something that if you would have asked me, I would have guessed maybe 50%, but unfortunately only 20% of enterprises today are on their cloud journey. They're deciding whether to do private cloud, public cloud, and now there's a great opportunity for enterprises to look at edge cloud for the future. So they can jump into edge cloud right off the bat. So you'll see a lot of activities in this domain, and that's why you're seeing these days a lot being written by cloud analysts and all of that on opportunities around edge cloud computing. So for both consumer and enterprise applications, edge cloud is going to be a huge topic. So then the big question is how are we going to do this, right? And I'll take you through kind of the story of how we came up with our idea of how to decentralize the cloud. And we call that the principles of edge cloud or principles of cloud decentralization. When I use the principles of cloud decentralization, a lot of people from blockchain communities started contacting me and telling me, oh, this is fantastic, we want to, and I had to explain to them that my view on decentralization is rather different from the mainstream of the blockchain community. It says all trust elements have to be removed. What we believe is that there are trust elements that are necessary in the network for certain applications. So we're not as religious about this, so I call this now the principles of edge cloud so that it doesn't get confused. The first principle of edge cloud, we call it meritocracy. And that means that the role of a device on the network should be based on its merit. So, for instance, if a device has a lot of CPU and can run big AI algorithms, it should be assigned to do it. We shouldn't have to relegate that to a server in a data center. Or if a device has really good connectivity, may be used as proxy for connectivity to other devices. So meritocracy is a huge principle, is one of the fundamental principles of edge cloud. The issue is to ensure that we can assign merit to a device. So there are challenges with that, obviously, but it's absolutely key to building a edge cloud system. The other is decentralized discovery. So one of the advantages that the servers in data centers have is that there's one entity that is kind of controlling all of these devices. They know exactly where they are. These devices are connected with fiber and Ethernet. They're very reachable and they're very discoverable. When you talk about edge cloud, now you need the ability for decentralized discovery. Because if you now relegate the discovery function to a server in a data center, then you haven't done a very good job in decentralizing, because now you have you need another trust element in the cloud. And that you can see, for instance, with concepts such as presence servers, right? Or notification services from the cloud to tell other devices that I'm here. So decentralized discovery, the ability for devices to be able to discover one another in a decentralized fashion, is key. And this needs to happen based on scope. And we came up with 3 scopes. Again, there may be other scopes that are important, but when we looked at it, we realized that there are 3 elements that are really important. Being able to discover other nodes based on the network that they're on. For instance, what are the devices that are on my local Wi-Fi network, for instance? The proximity, what are the devices that are nearby that I may be able to use as for edge cloud and connect to. And then account. What are the devices that are owned by Siavash, or they're owned by, I don't know, IBM or Microsoft, the enterprise, right? The account holder. So once you have these scopes, then you can do the discovery based on these scopes. The other important thing is clustering. Now, this is very important because the way we have designed communications in the past is with scale in mind, millions of devices connected to the network and then managing them. But the reality is most of the communication happens in very small clusters. In fact, in my first talk that I gave on decentralization a couple of years back, that I talked about Professor Dunbar out of Oxford. They came up with something called the Dunbar number. So he's an anthropologist and came up with the Dunbar number, which is 150. And that's the maximum number of close connections that we can have. And I really wish that they would have taught us when I was going to school. I think that some of the schools have started now for communication theory teaching the Dunbar number. But that is a big piece of information, because it says that at most in my lifetime I can have 150 close collections. That means on a daily basis my communication perhaps is limited to a cluster with just a few individuals, right? So I need to manage the communication on a cluster basis and not have to think that one device needs to talk to millions of other devices, right? So clustering, again, based on scope, is one of the other principles of edge cloud. The other important thing is microservice communication, meaning, again, that microservices are generally programs that are run on the back end to provide a service to an application. So to decentralize the cloud, a device needs to be able to act as a server. That means that it needs to be able to host a microservice, right? So any device should be able to support microservices in order to communicate with another device. And that's what we call microservice communication. If you don't do this, then you end up again with the central cloud architecture, because that's where the microservices are hosted today. The other important thing is collaboration. To make the system-wide edge cloud efficient, it's important that these devices be able to collaborate. So a good example with the scope of accounts. CLH has a mobile phone. I have game players. I have a couple of PCs at home. I have a smart TV and all of that. Now, these devices have all computing power and CPU and memory, and some of them may have really good connection. For instance, when I buy my new iPhone, instead of having to go and pay another $200 or $300 for extra memory, what if I could use the memory that is in my NAS, right? So if these devices can collaborate and share resources, then you're going to have at a system-wide a much more efficient system. The other important thing is dynamic resource instantiation. And for us as engineers, there are two important things. One is the signaling, and the other thing is data bearer, right? Now, when you have a decentralized system like that, if you start assigning fixed resources to these nodes, it's not scalable, right? Because now you have to, it's scalable to connect a few devices and give them signaling and data bearer resources within a for example, cell with a base station and a few devices that are active. But when you talk about decentralized cloud, but there's 200 billions of devices and anyone may talk to another, to have signaling and data bearer in a fixed way assigned, it's just not feasible. So resources need to be assigned dynamically. So for instance, if I don't have an IP address and I need to be reachable, I need to go to a proxy and be able to connect, the signaling channel needs to be assigned at the time that I need it. Not before, not after, right? So that's what we call dynamic resource instantiation. Last but not least is independence. And that comes from kind of being pragmatic, right? If now today we were struggling, we were a little bit late in doing the presentation because we were struggling to get my Mac to talk to the projector, and all sorts of issues with fragmentation in operating systems and all of that. And that's, if you want for devices to be able to communicate at microservice level, it has to be independent of operating system, it has to be independent of the networks that they're on, and it has to be independent of the location and proximity of devices. So initially I called this, what did I call it, Faye, do you remember? Being agnostic? Agnosticism. I can't, it was such a hard thing to say, to be agnostic to all of these things. And this is really important, because if you're not agnostic, then you end up with things such as DLNA. I don't remember whether you guys remember the industry initiative around DLNA. It never got anywhere because it had to be supported across different operating systems. It had to be supported across every network. So every new Wi-Fi standard had to put something. Every new cellular standard needed provisions for this. And so all of these things need to be independent, which when you have this principle of independence, then you end up that actually this communication network between these nodes has to happen at the application level, from the OSI layer stack. The only way to make these things independent to operating systems and networks is to do things at the application level, which was very weird for me because I'd never worked on the application level. And I had to going to bring a lot of people on the team in order to make sure that we have experts that know, for instance, HTTP and WebSocket and all of those things that basically operate protocols at an application level. So, challenges of it, Edge Cloud. So, it took us 10 years to create the system that we have today because there's a lot of challenging things to do. Device and network fragmentation is very, very important. To have, for instance, an iOS device talking to an Android device, to have a Windows device talking to a Mac at a microservice level, it's quite a challenge because they're not built to be able to communicate at that level today. The other important thing is increased uplink traffic, and I've tried to illustrate this in an example of, for instance, if I want to share a video with 3 people, using Central Cloud today, I do one upload and I put it on Facebook, for instance, or Dropbox, or whatever that trust entity in the cloud is, and then there are 3 downlinks of the video from my friends. If I want to do this in a decentralized fashion, then I would have 3 uplinks. And as you guys know, both in wired networks and wireless networks today, we have a fairly asymmetric network where downlink resources are more than uplink resources. So we need to make sure for the future that these networks become more symmetric. And a big driver for that is the fact that we are producing more content down there at the edge than we produce in the central cloud. A good example of this is that I forget exactly the numbers, but 1 day of YouTube is the equivalent of, 60 years of all the studios generating content, right? So we, as consumers, and also sensors and machines, generate millions of times more data. Therefore, these networks need to become symmetric for the future. So this is something that needs to happen anyway. It's a challenge that will be overcome in 5G, hopefully. The other important challenge is non-persistent devices, right? The cloud vendors in Central Cloud, they have complete control over their servers. Apart from certain anomalies, servers going down because of hardware issues or connectivity breakdown, generally speaking, servers are very persistent. Whereas when you talk about edge cloud, you're dealing with these non-persistent nodes that are coming and going. So if you want to treat them as cloud servers, you have to be able to deal with this non-persistency. So I said we have a pragmatic approach to edge cloud. So how did we at MIMIC come up with the solution around this? So, and it wasn't something that, we thought about day one and said, this is the architecture, and exactly was the way it was. We had to really evolve, iterate to get to where we are, and that's why it's taken us close to 10 years to complete it. The first thing, is something called the Edge SDK. So we came up with a piece of software at the application level that you can put it on a device, and you can have that device to act as a cloud server when needed, right? We used to say turn a device into a cloud server, but that's not correct. The key thing is the ability for a device to act as a server, and at the same time be able to act as a client, because that's how things work. When I want to communicate something with you, I'm the server. When you communicate to me, you're the server, right? So that role needs to be assigned dynamically. So with this piece of software, we made sure now the device has the ability to act as server where it's needed. So that means the device can host a microservice, right? It has a web server. It has all the elements, such as an API gateway. And I'll show a few diagrams to make that clear. I know it's a little bit hard, perhaps if you don't have that software background to kind of understand this. So I've tried to draw some pictures and make it more clear. But a very high-level picture currently is that the cloud is in the middle, and all the devices are connecting to it, and they talk generally through that cloud server. So whether it's a Facebook application or whatever application that you're using, that's the picture on the left. When you put the Edge SDK on the devices on the edge of the network, you create kind of a mesh that includes the central cloud itself. So the hybrid architecture of the cloud that I was talking about. But then you need certain functions. You need these devices to be able to register, authorize, authenticate. So you need a backend. So that's what we call the edge backend, right? So these are the two elements together that we now enable devices to act as cloud servers and together join and create an edge cloud. So let me show you so that it becomes a little more clear now. If you look at client-to-client communication today with Central Cloud, generally you have the client application being hosted on the device. If it wants to communicate to another device, it sends a message to the API gateway. API gateway looks at what microservice is needed. And generally, it will go to a push notification service that says, hey, another device wants to talk to you, right? And obviously, that device, through a presence server, has pinged that said that I'm here. So there was a bunch of stuff that was done in, before that. And then the communication happens. It's like it takes multiple messages and pings back and forth to do this. And the reason for that is that the API gateways and microservices are only in servers in data centers. And if you do this in a decentralized fashion, now you have the Edge SDK. You can host microservices on the devices themselves. You have an API gateway right on the device. And the client application, the first thing it's going to do is actually talk to its own API gateway and try to, if there's an HTTP request, to do it locally. So it's important, and in the hybrid architecture, it can also do this with the cloud, because some of the functions may need the cloud, right? So if the device, it makes sense to do a microservice level communication by another device in a peer-to-peer fashion, it does it. If it needs to go through the cloud for some reason, it should be able to do that as well. So that's what we have. We have the Edge SDK, and then we have a cloud backend that does signaling services. For instance, if one device is behind a firewall, you need to find a proxy and make communication possible so that the device is reachable. You need registration, you need authentication, you need multiple levels of security in order to make sure that Edge Cloud is private and secure. So the key aspect of this is that the edge nodes can now communicate directly, right, or through the cloud, and also that servers in data centers are still being used to manage communication. Now, when the edge cloud gets bigger, the reliance on these servers in data centers may become less and less, right? But at the same time, the number of devices are going up, the number of applications are going up, and I don't envision a day that we're going to completely eliminate kind of boxes that are only have server functionality, whether that's a fog computing node or a base station using MEC or a server in a data center. So it's going to be variations of these devices on the cloud serving. So by no means take me wrong that I say fog computing is not needed, MEC is not helpful, or the servers in the data centers are not there. But we have a gap, and the gap is that the device itself has to be able to act as a server. And that's what we have tried to accommodate. So to conclude, now, what are the benefits when you do this? So privacy is ensured because now the data remains as local as it can be. So just imagine as a consumer now, if I have videos or photos or music or whatever that I can share with my friends, I have a choice to have those on my device and serve it to my friends, right? I doubt that I am going to require a CDN for that because of the Dunbar number and Dunbar principle, because unless I become a celebrity and everybody wants to connect with me, I'll be just doing things in a cluster of very small nodes. So I'll be able to serve that myself. That means my data is going to remain private. My health data can be on a device that I own, and nobody from a regulation perspective can stop me from sharing that with doctors, right? Because that's the only way to overcome all the regulations. The reason doctors do not share your personal data is because they have to get your consent, and that takes days. You know, I don't know whether you've gone through that. I've tried that. I went to my doctor and said, okay, fill out this form, and then the form is sent to somebody else, and then 3 days later it gets signed. And a lot of it has to do with regulations, right? Regulations, and they're there for a reason. These are not outdated things, because if they don't do that, it may be abused, and also there may be all sorts of legal lawsuits. So if I now have my personal health data on my device, and I can serve it, then nobody can stop that, and nobody has a problem with it, in fact, right? And the doctors will be happy. The information from my health record is there, and I'm going to receive better health services. So privacy is obviously a big benefit of this edge cloud. Then latency, bandwidth, and all of that. And these are things that, you know, coming from a background of communication theory, I wish I would have had the time to be able to put an analytic framework for quantifying all of these gains, but it's very obvious when you hyper-localize communication, you reduce latency and you improve bandwidth efficiency. Vendor locking is not an issue anymore because it's a much more open platform. When you can have an iOS device talking to Android, to Windows and Mac, you've created an open platform by nature, right? So now you will be able to have the ability to choose Amazon or Microsoft or cloud as your cloud vendor and be able to communicate across different cloud vendor nodes. You can communicate across different operating systems, whether it's in Windows or Mac. The other important benefit is that now the developers that doing the software development can do their job much easier, because now they can build a solution, a microservice, and be able to host that on various devices instead of having to rely on third-party resources in order to do that. The benefits to the user are also significant. Not just from the perspective of data privacy, but from all aspects. When the cloud hosting cost goes down, right, at the end of the day, we as consumers and enterprises, we pay for that price. So we'll take benefit from the fact that these services have a much lower cost. We have much more control over our data, right? And it's much less susceptible to abuse third parties. At the end of the day, we're going to have a cloud that is cheaper, faster, and more private and more open. So that's why we should be doing edge cloud computing in the future. So that concludes my talk. Thank you very much.
Thank you very much.
Questions?
Thank you. Yeah. So now we open for the very interesting talk, and again, thank you. So now we open for the question from the audience. Yeah. Yes.
You say that for the aspect of reducing the latency
Yes.
and also the so exactly, I mean, in the network layer, so
Yes.
what has to happen between the control and the data plane so that you can discover who own that particular content and how this content get queued into the data plane or control plane in such a way that you can discover the microservice at the nearby peer or close proximity. What exactly on the technology network layer specifically?
Right. So there's, as I said, one of the most important principles is the principle of independence from the network function itself. Because if you want to depend on the network itself, then you have to evolve your edge cloud solution, and that is not going to be feasible. Because that has been, as I said, with the technologies such as DLNA or OCF, it was really hard to deal with these things at the network layer. So you've got to look at it at an application level, right? So the device at the application level should be able to say to all the devices nearby that I'm here, I am an Android device, I have a good connection to the internet, I have this much CPU, I have this much resources, right? And be able to be discovered in a cluster by others. And then that formation of fabric of cloud needs to happen at that level. So the protocols that we're talking about are not networking protocols. I'm now talking about HTTP, HTTPS, WebSocket, and those kind of technologies for the communication layer, right? That way is also this is counter to the cross-layer optimization and all of that. What this says is don't do any cross-layer optimization here. Just make sure the pipe on the network is as fast as it can be. It makes our job a lot easier. And then let the application do the discovery and the communication at the microservice level between the devices. Yeah, so for instance, there's a company in the UK called Lime Microsystems that has created a base station in a box. So they have a software-defined radio that is using x86 to build the networking functions, right? So now you can take this box and provide LTE connection to mobile devices, for instance, in remote areas, right? The issue that Lime has was that, okay, now I can connect these mobile devices, but the mobile device to be able to operate would have to connect to a data center somewhere in order to be able to host the application. So they used Edge and Edge SDK to now host the application on the device itself. And they overcame and this was with existing networking solutions such as LTE inside the box, right? That's one example.
Thank you.
Right? You have a way today with Snap, you upload all the stuff, and the Snap says, okay, I'll delete that content. I'll put it there, make it available for, I don't know, a small amount of time, and then we'll delete it. Trust us, we'll delete it. And I'm sure they're trustable and they can delete it as well. But a different way to approach this is that if I'm now the cloud server, right, to provide a link to that content and have my friends directly in a peer-to-peer fashion to stream that content to their device, especially if they are on a Wi-Fi network, for instance, near each other, right? So the context needs to be built into the application. It's a little bit more thinking involved at the application layer, right? A little bit innovation required. And in fact, this opens the door to a lot of interesting kind of smart approaches to understanding what microservice needs to be hosted where. The worst case is today. You upload everything to the cloud and hope for the best, right? That's what we do today. Now imagine if you bring the flexibility to the device. Now you can start, you have another degree of freedom to optimize this system and network end-to-end based on objectives that in the past we haven't really paid attention to. We talk about packet error rates, bit error rates, right? But now we have to talk about data privacy, cost of cloud hosting, energy, and all of these things that need to get optimized at this level. With Edge Cloud, now you have that ability to do, right? It doesn't mean that every application is going to take advantage of Edge Cloud. There's certain applications such as archiving. You want to archive something somewhere that is kind of protected by physical security, for instance. For that application, you have no choice but to do it in a server in the data center. But for instance, for archiving for my own applications, I may have a NAS at home, right? A network access storage, or a game player with terabytes of information. It may be good enough for me that I do my archiving from my iOS and Android and PC on that device, right? And have a copy of it, right? Or even say, I'm going to use all of my friends' resources, and we're all going to share all our resources and put a copy of our content on each other's devices. Now that opens up a lot of room for innovation around decentralized and distributed media sharing, content sharing, file sharing, and also application services, right? That's the concept. Oh, absolutely, and over time, with artificial intelligence, data analytics, I don't want to use buzzwords. These days, you say, well, AI is going to deal with this, but in fact, those are one of the good applications of AI, to understand where certain microservices on a network needs to be hosted. And there are concepts such as sidecar that allow you to do that, to decide where microservices are hosted, whether it's on the cloud or an edge node, and then attach that with an intelligent system that can assign that, and you're going to have better optimization.
Thank you very much. I can see a lot of the hands rising up. Maybe I go first with Professor Izzat, because he's raised hand before you. I'll come back to you later.
Thank you very much. I'm Izzat Darwaza from University College London. I mean, first, thank you for what I would say is one of the clearest keynotes I have listened to in many, many years, and for truly thought-provoking and educational. I really didn't know much about this subject until today. One of the key competitors of these technologies are the giants of this world, the people who actually, you know, knowledge is power, and the people who've got all the knowledge about us and our data, you know, from Facebook to Google to Amazon Web Services, etc. And so I'm convinced that this is technology that is, you know, that is going to be important and useful, but I'm not the important person to convince. I mean, you know, the users may be convinced, but there's a big political step to get these technologies taken. And so who should be doing this? I mean, is it the mobile operators? Is it the people who operate data centers, or is it really the big giants that have got you data and have got you by the neck, really, and all of us?
Right. When we started this journey, in fact, I was at Vodafone, and we tried to do this with mobile operators, where at the end of the day, it's the story of the blind man and the elephant. Everybody looks at their world through certain objectives, not necessarily, for instance, Edge Cloud doesn't have an impact on mobile operators selling more SIM cards, which is their core business, for instance. So you can't really expect them to be passionate about it and start doing it. The way we looked at this, that this is a tool for the developer. Developers are the ones that are paying Amazon, Google, and Microsoft. So if you educate the developers as to how to use Edge Cloud and train them properly to now use edge cloud as a tool, then the technology, the same people that are paying Amazon are now going to use edge cloud instead, right? So that would be the approach. A lot of training. Of course, universities, and one of the reasons I'm coming here to give a keynote, apart from telling you what we're doing, is to encourage researchers, universities to teach how to do this kind of stuff. That, if a full stack developer now can use edge cloud technology and microservices to build their applications, this needs to be taught in the computer science departments, right? For communication theory, you need to take into account that there is another step, and that's hosting of applications. That requires latency in communications, it requires bandwidth for sending stuff, and we as information theorists are the best ones on system level communication. And when you think about it, this is a system level communication. And we have always treated it as a bits going from one place to another and kind of lost track of that. The unfortunate choice of the client server architecture, the fixed architecture of the client server, is the underlying problem today. And there's no doubt in my mind that Amazon, Google, Microsoft, everybody needs to accept that in time. And they are doing, Amazon has Amazon Greengrass, right? There's a technology that brings some of the functions of the cloud closer to the edge. So they're taking steps, but they're taking steps within their own business requirements. They want to still have as much control as possible over their resources and be able to differentiate themselves from their competitors. So they're doing what is right for them. Developers need to do what is right for them. Reduce the cloud hosting costs. There's no benefit for Microsoft, Amazon, and Google to reduce cloud hosting costs beyond what people would tolerate, right? So that's what we're doing. We're going to directly to the developer community, people that are building applications to make this possible. I don't know whether that...
Absolutely, which is more of a democratic way of dealing with things.
Yeah.
Creators of technology, we're also the end users of technology. So, exactly. So, introduce myself. Too many wires here. Sorry, I'm Feyor Jamandi. I'm the colleague of Siavash Alamuti, the founder of Mimic. I was just saying...
No. I wasn't the founder of Mimic. Faye was the founder of Mimic. She was the one that actually brought this technology to Vodafone, and I had no idea about cloud, just like you, when you said this is new to me the first time that I heard the presentation. I had to go do a lot of learning in order to understand this technology. So a lot of this in terms of the thought process and the vision is really fake.
No, it's a teamwork. So what I was saying is that since you brought up the point of end user, as the creator of technology and developers of technology, we also have to remember that we are also the end users of technology. And if you think about it today, we are the producers of data as end users, right? It's our data that goes over network. And then we also pay for these mobile devices. We also pay for use of network. And yet we're the last one in the ecosystem and the chain that we make any money from that data. The value of our data is much more than getting an advertisement in return. So not only we need to get educated that, hey, there is a better way to develop your solution by utilizing the edge devices, but also we have to think about, and there is a better way to keep the data private, but we also have to think about there is a better way to generate revenue from my data for me. So it's kind of a new ecosystem and a new era that is about utilizing the edge resource for your application, keeping the data private, and also create a better economy of data for the end user and using your data as your currency.
So the one good
Thank you. Yeah.
one good analogy for this is Wi-Fi. Actually, in our industry, if you remember, there was so much resistance in the early days of Wi-Fi. You know, companies that were doing cellular communication, a lot of them considered Wi-Fi as the enemy. You know, if you recall, it was let's kill Wi-Fi with 3G will kill Wi-Fi, with 4G will kill. Now there's word that 5G will kill Wi-Fi, but without Wi-Fi and offloading communication into edge, right? We wouldn't have mobile communications today. 90% of the traffic goes on the Wi-Fi network. There would be no mobile phones without Wi-Fi today, right? So that same holds true for the cloud. Now, bringing the cloud and offloading the cloud to the edge.
Thank you, Faye, for chipping in. We got more questions. You is okay? Right, okay. No, actually, we still got one more question if anyone want to ask. You want? Yeah, you go ahead. You got one.
Okay. This is Adnan Yazıcı. I'm from Nazarbayev University, Kazakhstan.
Yes.
I was wondering how you can put these edge-related things and your talk in the perspective of blockchain, because
Okay.
there are lots of things actually sound same. And with respect to that, a little bit more specifically in the application layer, how you handle certain things here, for example, granting the request and all this stuff,
All right.
as like doing actually similarity to the blockchain technology where you have this dynamic hash structure. Do you
Right.
have, what is the state of art actually in this edge to
Right.
handle these things in the application layer?
Right, right. So the first important thing, I'm going to answer your last question first. The first important thing is the ability for the device to be able to actually host a microservice. So you need a technology like Docker or CoreOS, like container technology, that can host microservices, right? Obviously, you can't put a full-blown Docker and CoreOS on a device like a Raspbian or an Android device or an iOS device, right? Maybe in a few years, we'd be able to do that. But if you want this edge cloud, you need to address that problem. So a container technology that would run on smaller devices, right? Making sure that your memory footprint and storage footprint is small so that it can run on any device. There's a lot of optimization required. And the reason it's taken us 10 years to build this is exactly that. The other thing is you got to make sure when you have this edge SDK that different applications can actually get service from it, right? So that means you have to support multi-tenancy, right? Multiple applications being able to use the same resources of Edge SDK, right? Then you have to make sure that at a protocol level, these devices can do discovery, discover one another, right? And then you need also a holder of knowledge within the cluster, because otherwise you'll be pinging all the time. I'm sure you're thinking through all of those problems, right? And that's exactly that. We have a concept called the supernode. So supernode is a node in the cluster that is elected. And by the way, everything we do is very democratic, right? And there's no dictator in the network, right? So depending on the merit or based on the meritocracy principle, a supernode is elected and it's only a holder of knowledge, has no access to data, it has no control. It's just there to disseminate information to reduce the pinging on the network, right? So that's that. So then you need a web server, you need an API gateway, you have to build those things on the device. So that's from a technology point of view with a little bit more detail as to how to do it. The other thing is about blockchain. Now, blockchain is really business logic, right? It's about decentralizing a ledger, right? And what we've done now, we've decentralized the cloud. So a lot of blockchain companies came to us saying, well, this is really interesting because we have decentralized the ledger, but we're running on a centralized network. How can we take advantage of this, right? So their interest has been at that level. And there's a lot of ties between the blockchain community and cloud decentralization, right? So abundant number of possibilities to be able to improve the decentralization movement at a business logic level with edge cloud. And it's a major topic of research. You can do tons of research into optimization of processes, ledgers, and all of that using edge cloud technology. The other really important thing, so when I talked about edge cloud, the first thing is my device being used as resources for my application. That's the first step, right? But you can imagine that if you have the right business logic, right, that can be, in fact, enabled with blockchain, you can incentivize people to allow others to use your device for their applications. So pulling resources in the community to host different applications. But then you need a business logic. And that business logic needs to be decentralized. That's where blockchain will come in. Not, of course, blockchain as a protocol probably is not going to be very scalable. Some reduced complexity type distributed ledger system, right? That would allow this to happen. And that's another very interesting possibility.
Thank you. I think we overshoot the time a bit, but I still have a very quick. Okay, all right, it's okay. Thank you very much for very interesting talk. Everyone give applause to that. But before having a coffee break, can I ask you a favor? Can we all get together on the stage? If you can squeeze everyone in to take a photo, why not? ICT in 2019 in Hanoi. So let's be together, if you don't mind. Yes, please. Can I invite everybody to come to stage? And can